Hi everyone, thanks for joining today and welcome to today's webinar on proper tolerancing for consistent color. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I'll be moderating today's webinar. Presenting today is Tim Mao, our Applications Engineer and Technical Support Manager. Just a couple of things to go over before we get started. Due to the number of people that are attending today's webinar, we'll keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. I'll be monitoring the questions at the end of the webinar and we'll have time for a short Q&A session. Finally, this webinar will be recorded and you'll receive a link so that you can review it at your convenience. So with that, I'll turn it over to Tim to kick things off.
Thank you, Robert, and welcome everyone. Thanks for joining us today. As you can hopefully see on the screen, our topic today is about proper tolerancing for consistent color, or described another way, setting both an achievable and an agreeable tolerance. So let's go ahead and get started. Our agenda is we're going to talk about first color tolerance methods, reviewing some of the more dominant ones that are used throughout industries. We will then talk about selecting the right one, and then most of our time will be talking about setting achievable tolerances and using them to help you achieve color more easily, a consistent color. So color tolerancing methods. On this topic, color tolerancing can be done with a large variety of methods. There's many ways. There are probably hundreds of them, yet most folks are using these more common ones, and they include things like LAB. So LAB, or in most of these we're talking about a delta value, delta LAB, would be something similar to this, where the little pink dots on the screen are the samples that you've measured. Where those black crosshairs meet in the center would be where your standard or your target is located, and the pink dots are the samples you measured, and the box there would represent a typical LAB kind of tolerance. So let's review several of these. There's also LCH. This plot is the exact same standard and samples, but you'll notice that the box or the tolerance limits are rotated. That's a function of LCH and how it behaves. There aren't a lot of people still tolerancing with LAB and LCH, but we will talk about how important they are no matter what kind of tolerance we use. Then there's delta E, going to a single number tolerance. And in delta E, we will always get a circle. It's a spherical kind of tolerance. Of course, all these tolerances are three-dimensional. We're looking at them in a two-dimensional fashion here. And then the third type are what we call elliptical tolerances, and there's several different flavors of those. Delta E CMC, Delta E 94, Delta E 2000. Each of those are some progressions in the mathematics and the algorithms used to calculate these tolerances, but essentially all three of those use this elliptical kind of tolerance. And what's unique about those is that these tolerances, depending upon the color that you're measuring, will change. The math will cause it to change its shape and its size to agree really well with human vision. So selecting the right one. Obviously, the most common method of doing this is to select a tolerance that agrees with visual assessment. And X-Rite as a company, we encounter people who are entering color measurement for the first time. The reality is everyone has a tolerance, whether they know it or not. I'll use an analogy. When you're baking cookies, you have a tolerance. You know when you look at a cookie, whether it's been baked long enough or too long based on its color. We could essentially measure that and establish a numeric tolerance around it. So just like in that example, you, or maybe more importantly, your customer, can tell you whether a product is good or bad based on its color, and that in essence, is what we need to build to create a tolerance. And we'll talk about how we build that in a minute. But right now, we're really talking about what type of tolerance to use. And so one of the considerations to take in is this. This is some work that was done years and years ago. Using LAB as a tolerance, the middle column there shows you when these tolerance types were first created and by whom. And LAB, that 75% on the end, is telling us that basically 75% of the time, if you use a delta LAB tolerance, 75% of the time your eyes will agree with that LAB tolerance's assessment of pass or fail. If I go to LCH, I'll get 85% agreement. And if I go to CMC, I'll get to 95% agreement. And if even beyond, if we talk about DE 2000, we're going to get closer to maybe 98% agreement between the eye and visual. So that typically has a big impact on selecting which tolerance type we're going to use, because our goal is to ensure we're giving visually pleasing color. Now, mix into that the fact that tolerances may be specified by your customer. Your customer may be telling you, okay, we're going to agree to do business with you. We're going to buy X amount of this product from you, and it needs to fall within this tolerance. When that happens, that's the tolerance you're going to be using. We'll talk about some other things you can do to make sure you're producing good color, even within the directives of a customer. But if the customer is specifying it, you've got to meet your customer's needs. And then lastly, consider looking at multiple metrics. Just because you're tolerancing with one of these doesn't mean you can't look at all of them. And we will also review how we would do that and use that to help us in achieving good color. So let's move on to the meat of this thing, setting achievable tolerances. So the first is to build the tolerance on real samples. Some are good, some that are good, and some that are bad. If you're starting from scratch and you don't have any kind of tolerancing set up, it's very easy to get samples that are good and samples that are bad and base them on your visual assessment as well as your customer, right? So if you've got samples your customer approved and samples your customer disapproved of, let's use them. And the way we use them is this. We're going to measure these samples and then evaluate the data to determine the proper limits. So let me show you an example of that. So this is a plot from our IQC software. I happen to have as you can see, an elliptical tolerance. I'm using delta E CMC in this case. I've plotted a number of samples. The samples that plot with a black circle are within my tolerance as it stands right now. The ones that are pink are actually outside the tolerance. It can sometimes be confusing to see two pink dots that are almost dead center in that ellipse. And why are they failing? We have to remember this is three-dimensional. Those two pink dots, if I look on the right-hand side, are either too light or too dark from a three-dimensional perspective. So I can evaluate those graphically. I can look at them, and then I can also look at their actual color values. And you'll see each row begins with a red X or a green check mark. The red X means it failed my tolerance. The green check mark means it passed. And I happen to be using, I'll show you that. I'm set right now to use delta ECMC with a default pass-fail tolerance of 1.0. And so it's pretty easy to see things that failed and things that passed. However, in this particular instance, let's assume that I have determined that my sample 0001 and 0004 are visually acceptable, okay? And the customer has actually accepted them. Well, they're at 1.02 and 1.04. Then I probably don't want to use a 1.0 tolerance. And so it can be as easy as taking those samples, adjusting the tolerance now to 1.05, and now you'll see I have more samples that plot with a dark colored circle, meaning they passed. And in fact, my tolerance data has followed through, and I'm now getting more green check marks. So it can be as simple as that, but honestly, it's never quite that clear. It's very common when you go through this practice. And by the way, I would recommend you do it with more than 6 samples. It's better to do 10 or 20 samples that you're measuring. and knowing which ones. In fact, when I do it, sometimes the way I name my samples or my trials is I put accepted in their name and rejected in their name or something like that, so I can look through them very quickly. But it's not unusual to have something that's accepted with a higher delta E CMC than something that was rejected, and so you've got to kind of evaluate that stuff. It's easy in our software because you can click on the delta E CMC column and sort them to see and identify it, and then make a decision about, okay, here's where I need to put my tolerance in order to get the majority, as many of my good samples to pass as possible, as many as my bad samples to fail as possible. And typically what you will do is find the delta E, if I'm using this delta E CMC, the lowest sample that I want to fail, and make sure your tolerance is less than that so that you don't pass anything that the customer would reject. So that's one way for us to set an achievable tolerance. Another method, or another thing we want to do, is to make our tolerance actionable. So we use this phrase quite a bit in our trainings. The difference between good color and bad color is not a knife edge. And what we mean by that is, if my tolerance is going to be 1.00, that doesn't mean 0.99 is great color and 1.01 is awful color. Those two are essentially visually the same, right? So we want to be able to do something to take some action before we get too close to the edge of that tolerance. And so what you can do is you can set your tolerance to alert you when your color is starting to drift toward failure. If we happen to be trending color work that we're doing, okay? So in this case, I have, again, my default tolerance at 1.0, but I've set this thing called a margin. And setting the margin as I have is a 10%. I'm essentially saying 10% of my tolerance I want to call margin. What that means is that when I do my samples, I now get green check marks and red X's, but I also get yellow question marks. And in this example, I'm going to get a yellow question mark, and in fact, over on the far right, it's going to tell me that my pass-fail tolerance is margin. I'm going to get that for any sample between 0.90 and 1.00. Anything over 1 will, of course, fail. Anything less than 0.9 will pass, but anything in between is going to get marked as margin. And graphically, we can even show it like this. So here we've got green dots that pass, pink dots that fail, and the white ones that are in the margin. What this does, of course, is allow you to be able to take some action. If you're watching the trend of production over time, you start to see you're at small delta E's, and now your delta E's are getting larger and larger, and you get into the margin area, it means you need to stop and do something. It also enables your operators to have great confidence in a passing check mark, because they don't have to worry about, oh, it's green check, yep, keep on going. Whoops, I wasn't paying attention, and that green check mark was a 0.99. It was so close to failing that would be a problem for me going forward. So people will play with this margin. I've seen it as high as 0.3 or 30% of the tolerance being consumed in the margin. But they'll get this set, and then essentially it's anything you measure that gets a green check mark, you can have extreme confidence that that will pass your visual acceptance. Anything in the yellow you need to pay attention to, or maybe the yellow means we have to go do a visual assessment on this to validate. And then anything that fails, of course, is a failing problem. Robert, I think I skipped right past a poll question. Maybe not. We'll see. If I did, he'll pop it up for us.
Yeah, that's okay.
All right. All right. So another thing to think about when we're setting achievable tolerances is to use multiple metrics when needed. So we may choose an elliptical tolerance. Doesn't mean that's the only thing I'm going to use, because when we use those single number tolerances like delta E or delta E CMC, any of the elliptical tolerances, It's one number, but the only thing it does is pass or fail. Now, it does it really, really well. But if I get a number that fails, I don't know what to do to fix it. I just know it's bad. So what we would recommend is that you use LAB or LCH, whichever of those two three-dimensional color spaces you're more comfortable with, to direct your actions to correct the issue. And so here I've actually activated, I'm actually looking at, again, the same graph I was before with my CMC tolerance. But if we look back at the data again, it's not just showing me delta E CMC. I can go to the third sample, for example, see that it failed and go, okay, what's its problem? Well, it's about 0.7 dark, it's 1.1 units, 2 red, and 0.88 yellow. It gives me something to go fix. You know, the one at the very bottom is obviously way out, right? I've got problems. Second one from the bottom, it's very light. It's very much on the light side, and it's 2 red and 2 yellow. It gives me direction. So it doesn't change how we're tolerancing things, but it does give us some guidance on when I am out of tolerance, how do I go about proceeding to do something to bring it back within tolerance? And again, typically, if I was doing this kind of QC work, I'm probably not even looking at those delta LABCH when I got a green check mark. When I got a yellow, I'm immediately looking there to know what I need to go fix. You know, even that one, the very first one in the margin, right? It's 0.99. It's really close to failing, and that thing is seriously on the dark side. The delta A and delta B and C and H are great. Okay, it's dark. I need to lighten that color up if I'm going to continue making it. Otherwise, I'm going to drift too dark, probably. All right. Our last suggestion on setting achievable tolerances. If necessary, and it often is, you can use what we call an internal tolerance in addition to your customer specified or even your corporate company specified tolerance method. Let me show you what I mean by that. So this can be done by tolerancing both delta LAB or LCH and some form of a delta E tolerance. Let me show you what that looks like. So here you can see I've got a delta E CMC pass-fail tolerance. Then there's a little box kind of in the middle of that screen grab that says also test delta L, A, and B. And I've actually set limits, okay, for my delta L, A, and B, upper and lower limits. What that looks like is I'm still plotting the same things, but now it's actually plotting two tolerances. So in order for a sample to pass, it has to be inside the box and inside the ellipse, three-dimensionally. And what that can look like when I look at my data is this. So I had a sample before that was 0.9, the first two, 0.98 and 0.99, right? They were both labeled margin before, but now they're labeled failed. And you'll notice that that our data, the font in which the data is displayed turns red for the piece that failed. So those are labeled as the pass-fail for delta E CMC is failed, but the delta E CMC number is black because it passed, but it's red over in my delta L because it exceeds my upper and lower limit. So this gives me the ability to say, I know my customer says anything under 1 delta E CMC is good, but I also know if I give him anything over 2.4 in L, he's going to fail it. So it stops me from accepting a product or a color that the customer says he would accept, even though we all know that customer will tell you what their tolerance is, and you can give them product within the tolerance that they still reject. So it's a way to help control that. If you are going to use, I know I've been stuck on this, but I'm going to keep using delta E CMC as my example. It applies to any of them. If you have your customer specifies a delta E CMC tolerance of 2, let's say, and you know that even though they say that a delta E of 2, that you get some pushback from them, or you may get, rejections or whatever if you're greater than 1.75. You can use the margin to help you. So you set the margin so that anything between 1.75 and 2 is labeled as margin. You only ship them product that passes. And if things are in the margin, you go do a visual assessment, or maybe send it to them for pre-approvals. Depends on your customer. But you can use the margin to behave like a second tolerance. So you have your full tolerance that your customer specified. Use the margin to make that tolerance a bit tighter for internal use, and therefore you manufacture to a pass-only kind of tolerance, and anything in the margin is, open for debate. Visual assessment, maybe you do a visual assessment, say, yeah, they'll accept this one, we're going to go ahead and ship it, right? But you always are verifying anything that's in the margin. So the combination of those things can help you really be able to achieve color. And of course, all of this is, we could make tolerances really, really tight. Just say, okay, make everything to 0.5 DE, and then we'll never have to worry. But that's fiscally irresponsible, right? It's going to cost you tons of time and money to try and do that, and frustrate the heck out of your production process. It's not realistic. So to wrap all this up, we want to select a tolerance type that agrees with your customer's assessment of your product and meets their needs. Secondly, we want to use margins to alert you when color is trending toward failure. That one feature alone in the software is an extremely valuable thing to do. Like I said, especially if you've got a large number of folks doing color measurements and everything, you can have people who know that as long as they get a green check mark, they don't need to escalate that to anybody or anything. As soon as they get in the margin, okay, now we're going to maybe escalate it and have other people get involved to make decisions. And then thirdly, use three-dimensional color metrics to help direct you in correcting color issues. So when my tolerance tells me I'm out, I fail, go back to the LAB and the LCH numbers, because they're going to tell you why you failed. And that's a key question for you to be able to resolve things. All right, and so that brings us, this page has some links and information for you, as well as brings us to the point of answering some questions. Yep. So if you've got questions and you've submitted them, we'll let Robert go ahead and
looks like
fire
we
away.
have some already. If anyone else has a question, feel free to submit it now. So the first question goes back to the beginning of the presentation, I believe, when you were talking about tolerancing types. Someone was just asking where that data comes from when you had the 75%, 85%.
Oh, that, yes. It was actually a test that was done by the color measurement committee of the Society of Dyers and Colorists. Okay, big long answer, but color measurement committee, that's where the CMC and Delta E CMC came from. So they had an independent study done where they did that work, and had people use LAB and LCH and Delta E CMC tolerancing methods to generate pass fail, and then had like blind study kind of visual assessment done to say what was good and what was bad, and generated those numbers. So that's where that information came from.
And what software is being used to generate the data and graphs that you've been using in your presentation?
Sure. So the software that I was showing you, that's Color IQC software. There's also a version of it that is iMatch, which also has the QC portion built into it. That software package, both of those packages are in these promotions that are up there that are showing. It's our base quality control software package that has all of these abilities and functions, and of course much more.
And looks like we have one more. Do you ever use Six Sigma metrics for tolerancing?
So you can't do it directly in the software, but all of because the tolerance methods we're using are all CIE driven. And what that does, CIE, Commission Internationale de l'Éclairage, is the sanctioning body for color metric calculations and illumination and lighting for the entire world. And so we use those tolerancing methods that they specify to ensure consistency, and that ensures that no matter who you get your instrument from and your software from, that everybody is calculating all those things the same way and doing the tolerancing. That being said, our software, all the data tables that I showed with all that data in, can very easily be exported, or we can even set the software up to automatically feed it directly into a database, whatever kind of SQL database or whatever that you want. An Access database, you can copy and paste it directly into Excel and do all kinds of other calculations, statistical evaluations, and so forth. We do that on a daily basis ourselves, and we have many customers who do that. So if you have IQC software and you want to investigate how to do that, our support team will happily help you make those connections to be able to get the data where you can do some more statistical analysis.
We got a couple more, and so I'll just read these off quickly. Can you set
Sure.
LEB limit by specific color, or is it just across the board?
It can be done both ways, actually. So you have the ability to control it for each color, or you can do it within what's called a job in the software, where it maintains the same tolerances for all of your colors, but it can be color by color specific as well. Yep.
And then the last one, does ColorCert software also have the ability to do the margins for tolerance that you showed?
It does. It does indeed. ColorCert is a piece of software that's used in the printing, primarily in the press room and ink rooms of a printing facility, and it does indeed also have this same kind of a function. I don't remember right off the top of my head, I'm sorry, whether it's called the exact same thing, but it has the ability to give you a green, yellow, red kind of a response. That's pretty consistent through all of our quality control packages. In fact, our instruments, some of our portable instruments, you have the ability to send a standard to the instrument and then disconnect from the software, go take measurements, and our instruments, many of them have LED lights on them and stuff that will even turn green, yellow, and red depending upon the results of that measurement. So the operator doesn't even have to be connected to a computer to get that indication.
How do you know which illuminant observer space to use?
Yeah, that's really driven, again, probably by the customer. All right, you want to know, obviously, if you're producing something to be used in a home, right, versus something that's going to be outdoors, you need different lighting, because there's different lighting conditions in a house. It's something that's CFLs that are close to an incandescent kind of color producing versus out in daylight. And so those decisions are something that are just as critical as picking the tolerance, quite honestly. We've done a webinar in the past about more in depth about illumination, so I would recommend you can get to that on our website and get more information there. But it's kind of hand in hand. It's a tolerance. Tolerance on its own doesn't tell you everything, right? We need to know the tolerance. We need to know the geometry or the type of instrument being used. We need to know what illuminant observer is being used. All those things have to be equal in order for us to be able to get comparable data.
Okay, last question. Does it make any sense to have an LEB tolerance less than a delta E CMC spec?
Yes, it can. It's a color by color specific thing. Delta E CMC, even if we go back to the agreement, it was a 95% agreement. Well, that means there's 5% of error. And you may find a specific color where Delta E CMC tolerance, or more likely even your customer specified tolerance, is too big. And so you may say, I'm going to make an LAB tolerance that's even tighter. And the nice thing with LAB is that I can be more directional, I'll say, right? So if I have a color that they like this color, but they reject anything. I'm making blue, okay? And if my blue goes any bit too red, they're always complaining about it. Well, I can build an LAB tolerance then that only allows that color to be very slightly redder than the standard, but allows a lot of lenience on the green side, let's say, because that's where the customer prefers it. Essentially, you're talking about a situation where the color standard maybe isn't in the center of the color they really want. And so you can use LAB because you can specify different metrics for plus and minus, right? You build what's called an asymmetrical LAB tolerance to allow you to control that and only be passing things that the customer would truly accept. So that's a great question, because that's a perfect example that many people run into when they're dealing with customer who wants something always. Yeah, we like this color, but just make sure you're always on the green side or the red side or whatever, right? And that's a way to manage that.
Okay, we'll have to stop here. We have a few more questions. A lot of these are use case specific, so we can have someone follow up with you if you asked a question that we didn't get to. But I just want to say thanks everyone for attending, and again, you'll receive a link to a recording of this webinar. Thanks and have a great day.
Thank you all.